That's not your warm-up. There's your warm-up. There's your warm-up answers. So throughout the course of the day, I wanted to let you know that some people are making their lives a little bit more difficult by not using one of our 3 properties that we kicked off the chapter with. For instance, as I've walked around today and looked at some student work, I've noticed that in problem number 1, a lot of my students are, breaking, 48 down into like 16 and 3, and then 12 into 4 and 3, and then simplifying the radicals, and then reducing, and you get 2. Now, while that is completely algebraically legit, it's just a little bit long, don't you think? Just don't forget about our quotient property. If you have something like the square root of 48 over the square root of 12, you can just take 48 and divide it by 12. So that gets you 4, and then you root the 4 and you get 2. So don't forget about that quotient property from the beginning of the chapter. It can make your life easier, especially on your next quiz that's non-calculator. So, if you can take advantage of a property like that, do so. Now, when can't you use this property? Well, hey, if it said square root of 48 on the top and then cube root of 12 on the bottom, when your indices are different, you can't use the quotient property. Those properties only apply when the indices are the same. The root is the same. Number 2, usually pretty smooth sailing there. You guys are pretty good at combining like radicals at this juncture, especially when it's just numbers, not letters. And then number 3, 2 root 2. I used the quotient property again. I just took 24 and divided it by 3. I got 8, and then I just simplified the square root of 8. Regardless, you would have gotten the same response. Okay, does anybody have any questions on our warm-up? Because the lesson gets bumpy if you can't remember these from previous lessons. Okay, so the topic for today's lesson, multiplying radicals. And to some extent, we've already taken care of a little bit of multiplication with radicals because we've talked about the product property. Just to be clear, your next quiz is going to assess you on 5 skills. We talked about how to simplify radicals. We talked about adding and subtracting like radicals. Today, our major focus is multiplying radicals. And then all next week, those 3 days that we actually get to spend together, we divide radicals. So, just to review, we simplify, we added, we subtracted, we multiplied, and then next week we divide. So those will be the types of problems that are on your next quiz. Okay? We'll talk more about the quiz when we get closer to it. But I wanted to just foreshadow a little bit while I could. So with that, today's topic, multiplying radicals. And what you're going to see in the first example is a problem that looks like something we've already done. And I just wanted to review this skill with you real quick before I jump on into some more complicated multiplication. In general, we can use the distributive property in conjunction with our product property to expand a radical expression. And that's what we're doing in part A. I'm going to go ahead and take the square root of 3 and distribute it in to that particular set of parentheses. So I have the square root of 3 times 4 root 2. I would bring down my minus, and then I have to also distribute the square root of 3 to the square root of 12. And now it's just the product property. Remember that multiplication is commutative, so you could do the multiplication in any order that you want. For instance, in this first term, I would probably multiply together that 3 times the 2 underneath the radical to simplify and get 4 root 6. And that's kind of done there, huh? And then in the second term, I have the product of the square root of 3 and 12, or the square root of 3 and the square root of 12. 3 times 12 is 36, so I'm going to go ahead and take the square root of 36, which is a number I know. The square root of 36 is indeed 6. So that's simplified pretty easily. I have a question for you. Famous question. You might have the same. Am I done? Can I combine these? No, I can't combine them, so I'm done. You can't combine and you can't simplify, so that marks the end. Everybody okay with that? All right. Part B is just a more advanced version of the distributive property You know it and love it as FOIL. Do you see how you have two parentheses multiplied together? That's your visual cue that you have to FOIL. So that's what we're going to do. That's our major new material for today. So I'm going to do FOIL. What's F stand for? First, I hear it around the room. Good job. Square root of 5 times the square root of 5. Using our product property, that's the square root of 25. Oh yeah, which is 5. Outers would be the outside parts of the problem. We have the square root of 5 times 2. What's that? Careful. Is that what you were going to say? Perfect. I'm just so glad. That's very good. Every once in a while I hear a square root of 10 and I'm like, oh heavens, it hurts. Yeah, no, you can't multiply something that's outside the radical with something underneath. Ever. Square root of 5 is crazy decimal. Shouldn't be multiplying it with 2. I stands for inners. So we have negative 5 times the square root of 5. That is negative 5 root 5. And then the lasts. You have negative 5 times 2. That's pretty easy. Those are both integers, so you can multiply those together. You get negative 10. Remember the last step in your FOIL, though, isn't just finding F, O, I, and L. You have to add F plus O plus I plus L. So you have to find the sum of those terms. What you're going to notice is a lot of the time, not all of the time, but a lot of the time, your firsts and your lasts are like terms. You could combine those. With the same idea in mind, your O and your I oftentimes also combine. So we're going to go ahead and add the F and the L. 5 and negative 10 is negative 5. And then 2 root 5 minus 5 root 5, that is just, oops, marker's upside down, negative 3 root 5. So I just sort of used my product property to help me find F, O, I, and L, and then I combine my like terms at the end. Okay, does anybody have any questions about that? You got something for me, Rick? Nope. All right, that was a good time. We should do it again in part C. So let's do that. Part C setup is exactly the same. I'm going to take F, O, I, and L and find them. F stands for find the product of your firsts. So that's the square root of 2 times the square root of 2. Product property says that's the square root of 2 times 2, which is the square root of 4. Square root of 4, since 4 is a perfect square, that evaluates to 2. And then we're going to multiply our outers together. So we're going to multiply the square root of 2 times the square root of 3. The product property says that I can multiply the 2 times the 3 to get the square root of 6. My inners is negative square root of 3 times square root of 2. Product property again says that's negative square root of 6. And then my lasts, I have negative square root of 3 times positive square root of 3. That's the negative square root of 9, which is actually negative 3. So what you're going to see is that my first and my last do again combine, and my OI combines as well, my outers and my inners. So these are like terms, and so are these. So I can put them together. 2 and negative 3 is negative 1. Square root of 6 minus the square root of 6, those go away. So your answer to that problem is just negative 1. Questions about that one? All right. Next one. You're probably saying, Mrs. Lucas, we can only FOIL if we have a product of 2 binomials. Well, part D is actually a FOIL problem in disguise. Remember, one of the big rules I need to teach you is that you can't distribute an exponent into a set of parentheses when there's a plus or minus in the parentheses. So for part D, we actually have to write it out twice. if you want to square root, if you want to square the square root of 5 plus 1, you have to first write it as the square root of 5 plus 1 times itself, times the square root of 5 plus 1. Do you see how it's a FOIL problem in disguise? Watch out for that. So yeah, I'm going to go ahead and FOIL this guy now. My first square root of 5 times the square root of 5, using my product property, that evaluates to the square root of 25, which is 5. Maybe you're noticing a pattern with the firsts. Are ya? Good. Your outers, we'll use and abuse that pattern a little more next week. For right now, you're kind of just writing it out. Square root of 5 times 1 is the square root of 5. My inners is 1 times the square root of 5, and that's the square root of 5. And then my last is just 1 times 1, and that's 1. Again, I notice that my first and my last are like terms, and then my outers and my inners are like terms. So if I want to add these together, I do 5 plus 1, and that's 6. And then 1 square root of 5 plus another square root of 5 is 2 square roots of 5. Any questions about that? All right, let's have you give it a try, shall we? Okay, so here are the final answers to your first independent practice set. If you're done, like I said, look up, check yourself. As I walk around, it looks pretty good. Eddie, did you get them right? So this is where, if you're done with the notes for today, you would pick up within the video, and then you're going to finish watching the notes tonight. And I'm just going to hit record again when you guys leave. Keep in mind you do have 2 assignments, right? Yes, you do. You have to fix the bookwork from last night just in case you messed it up. Hey, happy Halloween. Have a great weekend. Okay, so now we need to take some time to practice with the distributive property in FOIL when there are variables involved in our radical expression. The problems are very similar to when there are no variables in the radical expression. We're going to go ahead and take some time right now to distribute the square root of 3x into that set of parentheses. And after we use that distributive property, we're once again going to use our product property. So we're allowed to multiply the things underneath the radicals together. And it would be nice if we could combine these. So now they're very much like problems from last night on your homework, problems from yesterday's lesson. We have to simplify before we can hope to combine. So what I see here is a radical that could be simplified. I could take the square root of x squared. So that radical there is going to simplify to be just 4x times the square root of 6. Because if I take the square root of x squared, I just get x. The next radical, I notice I can simplify the square root of 36, but the square root of x doesn't simplify, so that changes to be 6 root x. What I also notice in addition is if I look at this guy right now, I need to make some room here, we get 4x times the square root of 6 minus 6 times the square root of x. Those radical parts are not the same, so we can't combine. This problem's actually done. So we get 4x times the square root of 6 minus 6 times the square root of x. For part B, we are going to FOIL. We do our first by taking the square root of 3x times the square root of 3. This gives us the square root of 9x. The square root of 9 is a part of that radical that you can simplify. So that particular radical expression simplifies to be 3 root x. Your outers are going to simplify, or rather combine. We're going to take the square root of 3x times the square root of x. This gives me the square root of 3x squared. And very similar to your firsts, you could simplify part of that radical. I can't take the square root of 3, but I could take the square root of x squared. Square root of x squared is x. And then the square root of 3 would be left over. My inners is going to be negative 5 times the square root of 3. And my lasts would be negative 5 times the square root of x. And very typical of our FOIL problems, you're going to see that you do have some like terms that you could probably combine, namely 3 times the square root of x and negative 5 times the square root of x. If you put those together, you get negative 2 times the square root of x. And even though both of these radicals here have the square root of 3, one has an x and one doesn't, which means you can't combine those, so they just come down for the ride. And that's our answer. For reinforcement, we could FOIL again here in part C. I'm going to find the product of my firsts. So I'm going to take the square root of 2x times the square root of 2x. That is the square root of 4x squared, which simplifies. The square root of 4 is 2. The square root of x squared is x. I'm hoping you're picking up on a pattern of those. We take a radical times itself. We'll talk more about that pattern when you come back next week. And then we have the square root of 2x times 4. For your outers, that's going to be just 4 root 2x. Your inners, negative 4 times the square root of 2x. And your last is negative 4 times 4. And that's negative 16. I'm going to look for some like terms, and I do see them. 2x doesn't have any friends, but 4 times 2 root, I'm going to highlight it. 4 times the square root of 2x and negative 4 times the square root of 2x. Those are actually like. Not only are they like, but they're opposites. So if I add them together, I get 0. So they kind of get rid of each other a little bit. And then we get minus 16 as our last. And you see how there's no radicals in that expression? That's so nice, and it's going to come in so handy when we rationalize denominators. So that one right there is a preview of coming attractions. And just like the last example we did together in class, we have the case where you can't distribute an exponent into a quantity where there's a plus or a minus. So we actually have to FOIL this. This is a FOIL problem in disguise. So I'll do my F, my O, my I, my L. First stands, or F stands for find the product of your first. So you are going to multiply the square root of 3x times itself. You get the square root of 9x squared, and that's just 3x. Your outers is going to be the square root of 3x times 2, which is the same as 2 root 3x. Your inners is also 2 times the square root of 3x, or 2 root 3x. And your last is just 2 times 2, which is 4. And then we combine our like terms together. What I see is that 3x doesn't have any buddies, but I do see that we have 2 root 3x and 2 root 3x. That makes 4 root 3x. And then I have my lasts, which is 4. So that is your example there. So now you get to try. You're going to want to press your pause button and give these 2 practice problems a try, and then I'll go ahead and show you your answers. Okay, and there are your answers to your independent practice problems. Just to grab your attention there for a second, for number 1, you're going to see that when I FOILed, I got x. From my first, my outers was negative root x, my inners was negative root x, and my last was 1. When I combine my outers and my inners, I can think of a coefficient of negative 1 in place of that negative. So when I combine my OI, or my outers and my inners, it's like I'm taking negative 1x and adding it to another negative 1 square root of x. I'm sorry, I think I misspoke. When I have my outers, I have negative 1 root x. My inners is also negative 1 root x. If I put negative 1 root x and I add it with negative 1 root x, I get negative 2 root x. So I highlighted that just so it'll grab your attention. And then number 2, when you FOIL, you actually don't get any like terms, real simple, similar to the other independent practice we just finished up with. So you just kind of FOIL, and it is what it is. There's no like radical parts or no like terms period in your response to number 2. All right, that is it. Don't forget to fix your bookwork from the night before, and we'll see you in class very soon.